So we're in the process of teaching my 13-year-old daughter how to babysit her 6 younger siblings. No small feat, as you might imagine. And we were just sitting back on the couch watching her, and the 7-year-old walks to the garage door and just walks out the door. And she sees it, looks back. And we go, whoa, 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 whoa. Learning point number 1. Don't let the children leave the house without asking, where are you going? That's the job of the network layer. And this is where you see a difference in naming convention between the OSI model and the TCP/IP model. TCP/IP is the internet layer for this layer, which really represents its mindset when it was built. This is when they designed the protocol to describe, to say, here's how we see the larger network. Whereas OSI was designed to be a little bit more generic. See, here's the key. There's way more than just 2 protocols out there. There's OSI, there's TCP/IP, and back in the day, there was IPX/SPX, DECnet, AppleTalk. We could just keep going down this list of all these protocols. We don't hear much about them anymore, but they existed. They all had their own run to try and take over the network. And yes, they all failed, and everything is dissipated, sure, into TCP/IP, right? Everything's dissolved into TCP/IP. But that's one of the big things that we see when we're looking at the OSI model, is it's designed to be a little bit more generic. The network layer could be the network layer for any protocol. Essentially, it represents the logical addressing. Where are you going? Where have you come from is the questions that it's asking. In the example I've been using through this discussion of the OSI model, we have a cashier application that's making a purchase of a $5 fidget spinner and registering that purchase over here on the cashier server, whatever application would be hosting that. And we talked about how that application prepares the data, starts the session, make sure that that data can be understood by both sides. We've talked about how that application chooses whether it's going to be reliable and use TCP and UDP. If it's going to be unreliable, I should have put that first. Unreliable communication, reliable communication, but really useful for real-time communication, right? And this is used for the majority of applications that we have nowadays. Just fly-by review. Now that data passes down here to the network layer, which is considered the layer of logical addressing. I'll just put logical add right there. The bonus, the great thing, I'm trying to think of what word to use there, about the logical addressing is you and I are in complete control of it. We design our networks. Perhaps you've heard of things like IP address design, subnetting, right? One of those keys, DHCP and allocating the address, documenting what IP address goes to which devices. All those conversations are focused around you and I designing the logical addressing for our network. So it's up to us. If we want to go to this network, which might be store number 1 that is accepting these purchases of fidget spinners, and set up the IP addressing to say the addresses of this network will come from the 10.1.1.0 network /24. We're talking about the subnet mask. And I don't want to get heavy into the subnetting and addressing that we would use to set this up. This device might be device number 50, so 10.1.1.50, right? We came up with that. We assigned it. And it's going to communicate over here to this device, which maybe is 10.50.1.20. Which might be a completely different network. And this device communicates across that network. We design that addressing. We assign those addresses to the devices to make them function across the network. We assign those addresses, but once it's assigned, they will be included in the communication and in the packet that's being built as that data passes down the OSI model. The data itself is the registration or writing of a database of that $5 fidget spinner transfer, right? In front of that is that source and destination port number. We're using TCP for that communication, and it defines the source and destination port number that will use. Then it adds on to the front of that the source and destination IP addressing, right? Where did this communication originally come from? That'd be 10.1.1.50. Where is it finally going? That's 10.50.1.20. That is the major components of the information in the IP header. And this is why we call it TCP/IP. TCP is the favored protocol for the majority of the applications that we use today. It's reliable. IP is the favored protocol that we use to address it and make sure it gets from the original source to the destination and back. And that is what happens at the network layer. I hope this has been informative for you, and I'd like to thank you for viewing.